This program is in no way affiliated with the show Cops. Este programa de ninguna manera está afiliado con el programa Cops, Policías.
Bad boys, what you want, what you want, what you gonna do when Chevy John don't come for you?
Keep your hands on the car. I'm doing my job.
Daddy, what you wanna do, what you gonna do? Yeah. Bad boys, what you gonna do? What you gonna do when they come for you? Bad boys, what you gonna do? What you gonna do when they come for you? Nobody now give you no break. Police now give you no break. That old soldier man I give you no break. Not even your eyes now give you no breaks. Hey, hey, bad boys, what you gonna do? Or what you gonna do when they come for you? Bad boys, what you gonna do? What you gonna do when they come for you?
So me and my partner here, Officer Eddie, we heard some things are going down at these apartments. Someone's breaking some type of law. So we're gonna go around and just check it out a little bit. Alright, so me and my Officer Edward, we're about to go check out this room right here. It said there's some illegal activity, so we're just gonna check it out a little bit.
1034. Hey, open the door.
Hey, I think we're going in.
Let the bus in.
Hey, put your hands up, put your hands up. Hey, don't move, hey, don't run. We already got you, man. We already got you. We already know you've been doing some illegal activity over here. Yo, Officer Edward, check the evidence, check the evidence.
Man, you messing up. You messing up Newton's third law.
I'm doing the thing wrong.
That's what they all say.
That darn criminal Ace Boogie. He broke the law. Newton's third law to be exact. This was a problem that he was trying to do. A 10-kilogram mass initially at rest experiences three forces. One north with magnitude of 10 newtons, one east with a magnitude of 20 newtons, and one northeast with a magnitude of 30 newtons. Find the resulting acceleration. After 10 seconds, assuming the forces continue to act while the object is in motion, what is the object's velocity and how far has it traveled? So first we're going to begin by doing a free body diagram. So we started to label. The y-axis was 10 newtons. The x-axis is 20 newtons. The mass was 10 kilograms. The angle is 45 degrees. And the diagonal force was 30 degrees newtons. So now what we're going to figure out is we're going to find the forces in the x direction. So we're going to use the formula f of x plus the diagonal forces times the cosine of theta. So what we're going to do is we're going to plug in the numerical values. So as you see, 20 for f of x right there, plus 30, which is the diagonal force, cosine 45 degrees, and it equaled 41.2 newtons. Then we're going to do every force in the y direction. So we got f of y plus the diagonal forces times sine theta. So as we plug in the numerical values once again, we have 10 coming from here. We have the diagonal force, which is 30, times sine theta, which is 45 degrees, which equals 31.2 newtons. So now at this point, we're going to find the magnitude of the resultant force. The formula is the summation of all the forces in x direction squared plus the summation of all the forces in the y direction squared, all square rooted. So we plug in 41.2 right here, and we plug in 31.2 right here to get 51.7 newtons. So now we're going to use this to find acceleration, which is the sum of all the forces divided by the distance. 51.7 newtons divided by 10 equals 5.17 meters per second squared, which is our acceleration. So now we're going to use the opportunity to find our direction. So we're using arctan sine over cosine. The sine, as we go back to the top, is y, and the cosine, as we go back to the top, is x, which is 41.2. So 31.7 over 30 over 41.2, which equals 37.1 degrees northeast. Now we're going to use our kinematic equation to find the velocity. So as we do, the final velocity equals the initial velocity plus acceleration times time. So we're going to plug in our values. the initial velocity was 0, plus acceleration, which we figured out was 5.17, and then the time. Time was 10 seconds as stated in the problem, and we got 51.7 meters per second. So now we're going to use this velocity to try to find the distance. So we're going to use the distance in the x direction is x naught plus v initial times time plus half of the acceleration times time squared. So we got 0 for the beginning distance, 0 for the initial velocity as stated earlier, plus half acceleration, which was 5.17 times time, which was 10 seconds squared, which equals 258.5 meters. And that is how you solve the problem of Newton's third law. Alright, criminals, you are now under arrest for breaking Newton's third law. Please get on your knees. Officer Edward, read him his rights.
An object at rest will stay at rest, or an object in motion will stay in motion, unless acted upon by outside force. Force equals mass times acceleration. And for every reaction will be opposite and equal reaction.
So you see, young buck, you see how my force on my hand is longer than is harder on your shoulder than you are? That's why you can't get up. Alright? Now, I think you didn't understand that, so this is just a warning. The next time you do it, you're going to be in serious trouble. Stand up, young buck. Officer Edward, let's get out of here, man.
Alright. Hey, what is this? What is this? Is this dope?
That's the sound of the police. That's the sound of the beast. That's the sound of the police. That's the sound of the beast. That's the sound of the police.